Hello friends, welcome to in this video. In this video we will understand the concept of toughness and modulus of toughness. Again, this when we say resilience, then this resilience is up to the limit of proportionality, that is up to yield point, the energy stored within elastic limit. And when we talk about toughness, then it is the ability up to or the energy stored up to fracture point. Now in this particular diagram, this is the fracture strain. So what is the energy stored by material per unit volume in up to fracture point is known as the modulus of toughness per unit. When we say per unit volume, then it is modulus of toughness. Now this is the ultimate stress point, and this one is the fracture point, and this one is the yield stress. Now I calculated the average and consider it as a rectangle. Consider this one as a rectangle, like x, o, and this is x, and this is y, and this is z. So this complete looks like a rectangle. Now in this rectangle, whatever the energy stored, this sigma average is calculated like sigma ultimate plus sigma y divided by 2 average multiply with this length. This is the sigma average. So multiply with fracture strain, right? So up to fracture strain, what is the energy stored in the material is known as this is sigma average actually. This is sigma average, is known as modulus of toughness. And the toughness is the total energy stored in a material up to fracture point is known as the toughness. Actually, toughness refer to the resistance against impact loading. Now for example, we see that the cork ball or the cricket ball. Now what happens to the cricket ball? When we make first shot or second shot, consistently energy is stored in the material. Energy is getting stored in every shot in the material. After some time, when the stored energy stored reached this fracture strain point, then the crack will appear on the ball and the ball will fail. So the failure criteria is due to this particular case, right? So you got the point that what is modulus of toughness and what is toughness, right? Now if we see that mild steel and other ductile metals are more tough than brittle metals, and brittle metals are less tough. So we can say, because here again this is sigma u and sigma y by 2, so we can say that mild steel is more tough. If we draw the diagram, stress strain diagram of mild steel and high tension steel, then you will see that in case of high tension steel, material will fail up to this point, but in case of mild steel, the fracture strain is too much. So the fracture strain is this much. This is the fracture strain for mild steel, but for high tension steel, the fracture strain is only this much. So we can conclude that the toughness of high tension steel is tough is less than mild steel toughness. So it is very clear that fracture strain is more in case of MS and not in case of high tension steel. So hopefully you understand the concept of toughness and modulus of toughness and how the energy is stored in this.